this diagonalization. This is our question for the modal matrix, and then afterward we find the characteristics equation, which is the a minus lambda. And afterwards we do the addition of diagonal elements in S1. This is 5 plus 2 7. Then afterwards we find the determinant, and determinants means the multiplication of this elements. 5 plus 2, 5 into 2 is 10, minus this 4 into 1, 4 is equal to, and after it we find the lambda 2 minus 7 lambda plus 6 by the formula is equal to 0. We putting the values in the formula, and then afterwards we find the values of this from the calculator. Lambda 2 is equal to 6. Then after it we can do the write up the eigenvalues, the eigenvectors are corresponding to the eigenvalues which is lambda 1 is equal to, it is a minus lambda I, which is x is equal to 0. It means the a means this values 5 4 1 2 minus 1. Minus 1 means the lambda 1 value, it is this one, and afterwards we can multiply it. And this is x1 x2 is equal to 0 upon 0. By multiplying it we get the values 4 4 1 1, and this x1 x2 then afterwards we can consider an equation x1 plus x2 is equal to 0, and x2 is equal to t, x1 plus t is equal to 0. Then after x1 we shift the t to right side, then after the t change the sign, minus t, x1 is equal to minus t, and afterwards x1 is equal to minus t upon t, and afterward the t is equal to 1, then we get x1 is equal to minus 1 upon 1. Then afterwards we can do the same equation for the next lambda value, which is lambda 2, which is the 6. This 6, then we do the same step for again for this, the eigen vector is correspond to eigenvalues and afterwards we can do the same step, which is a means now a we can consider to this last equation. this is x1 x2 and is equal to 0. We can consider the equation. X1 minus 4x2 is equal to 0, and then x2 is equal to t. We can x1 minus 4t is equal to 0. Then afterwards we can shift 4t to this side, then it is negative, then afterwards it get positive 4t. Then after x2 is equal to 4t upon t, then t is equal to 1, and it is converted into x2 is equal to 4 upon 1. Then afterward the modal, we consider the modal matrix P is equal to x1 x2, then the P is equal to minus 1 4 1 1. This is P inverse. This is the formula for conversion of modal matrix into the diagonal matrix. P inverse of AP is equal to diagonal matrix B, and afterwards P inverse is equal to, we consider the this P here 1 upon 5 minus 1 minus 4 minus 1. Because of this we can change the sign of these elements. This is positive, this is here negative, then we can change it here positive, and these all three elements are we can change from positive to negative. Then afterwards we can do the P inverse of AP is equal to minus 1 upon 5 1 upon minus 1 minus 4 minus 1. We can multiply 8. Then after we can multiply it, and afterwards we can get like this answer. This is the diagonal element, so we can know that this 1 and 6 are diagonal elements. So this is the lambda 1 and this is lambda 2. So we can say that this is the diagonalized. So hence prove that this P inverse gets the diagonalized, this P inverse AP get diagonalized, and we can get a final answer.